Hi everyone, welcome to this new series on environmental economics through the lens of microeconomic theory. My name is Thais Vilela and I'm an environmental economist. In this first video, we'll explore a fundamental question. What does economics, a discipline often associated with markets, prices and profits, have to do with the environment and nature? So without further ado, let's get started. To give you an idea of what we'll be covering today, I'll start with the concept of scarcity and then see how it applies to natural resources and ecosystem services. Next, we'll discuss opportunity cost and trade-offs, ideas that are central not only to economics in general, but to environmental economics. And finally, I'll go over a few examples to illustrate these concepts in practice. So let's start with one of the most fundamental ideas in economics, scarcity. Scarcity means that resources are limited. We can't consume or use them endlessly without consequences. Because of scarcity, we have to make choices. In the sense that when we use a resource for one purpose, we give up the opportunity to use this resource for something else. That's what economists call the problem of allocating scarce resources among competing use. To illustrate this idea, let's suppose an economy that has only one resource, land. So in this example, the horizontal axis represents the amount of land devoted to agriculture. So moving to the right means more land is used for farming. The vertical axis represents the amount of land preserved in its natural state. So moving up, the y-axis means more land is preserved. The curve in blue represents the production possibility frontier. This shape reflects the choices society can make between the amount of land that it will use for conservation and the amount of land that it will use for agriculture. From its shape, you can infer that using more of one good means using or consuming less of another. So an interesting feature of this curve is that when there is a large amount of one land used, such as forest, converting a small portion of each to agriculture has a relatively small impact on the remaining conservation value. However, as more and more forest is converted, each additional unit of land cleared comes to a higher cost in terms of lost conservation. So in other words, when one type of land dominates, lots of forest, little agriculture, the sacrifice for a small change is small. So as you move along the curve, converting more forest becomes increasingly costly because the remaining land is more valuable for conservation. Another interesting feature is related to efficiency. Any point in the curve or frontier represents an efficient use of land in the sense that you cannot increase the use of land for one specific use without decreasing the use of land for the other use. On the other hand, points inside the curve represent inefficient allocations. It is possible to increase both agriculture and conservation lands without giving up either. This means that the land is not being used optimally. Points outside the curve, such as the one in the figure, show allocations that are not feasible because there are no resources. Remember, land is a limited resource. I believe once you understand the allocation problem and understand that natural resources are limited, it becomes easier to understand the relationship between economics and nature. Understand that the main problem we want to solve is the allocation one. Because of natural resources scarcity, society must make choices about how to use these resources. every decision to exploit a resource for one purpose, such as agriculture, energy, or urban development, comes at the expense of alternative uses, including conservation and other ecosystem benefits. So it should be clear at this point that we as a society need to make a choice which involves, in a way, some degree of prioritization. We must decide which uses are more important or valuable to the society under the circumstance or context. Considering our previously example, this means deciding how much land to allocate to agriculture and how much land to allocate to conservation. Another example would be deciding how much water to use for irrigation versus ecosystem maintenance. One important aspect of the production possibility frontier is that it does not tell us which point is best. Choosing a specific point requires careful consideration of society's goals, values, and priorities. For example, how much we value food production versus biodiversity, or short-term benefits versus long-term ecosystem services. Two very common concepts in economics are trade-offs and opportunity costs. We have already covered both of them here without naming them. The first concept is the trade-off. A trade-off occurs whenever choosing more of one thing requires giving up something else. The second concept is the opportunity cost, which is closely related to trade-offs. Opportunity cost is the value of what we give up when we make a choice. Using our previous example, the trade-off is if we increase agriculture, we lose some conservation. In other words, moving from point A to point B means more agricultural land and less conservation, less forest. The opportunity cost of this decision is the loss of X hectares of conservation and consequently the loss of all the ecosystem service associated with those hectares that have been converted. Now you might be asking, is moving from A to be good or bad? The answer is it depends. It depends on the costs and benefits associated with each point and on what society valued the most. Okay, so now let's move to some examples. The first example comes from a study published this year in Nature. The goal of this study was to evaluate the trade-offs between agricultural production and ecosystem services under 3 different land management scenarios in China: business as usual, ecological restoration, and sustainable intensification. The study found a very interesting result related to the sustainable intensification scenario. Under this scenario, crop yields increased due to the adoption of advanced farming technologies and management practice. As a result, the total agricultural output value was also higher under this scenario. And that is interesting because it shows that it is possible to increase production without simply expanding farmland. In other words, by producing more with the same amount of land. When it comes to ecosystem services, the ecological restoration scenario, as expected, since it focused on restoring natural habitats, provided the highest level of ecosystem services overall. Compared to the business as usual scenario, this approach increased water yield, soil conservation, carbon sequestration, biodiversity, and landscape aesthetic. However, the sustainable intensification scenario had the lowest provision of ecosystem service among the 3. And that result was somewhat surprising, at least for me, since these practices were designed to minimize negative impacts on the environment. The study also included a qualitative trade-off analysis, which you can see in the table on the right of the screen. This table highlights the trade-offs between crop yield and ecosystem services. So when farmers try to increase yields using intensive practice, they end up degrading water quality, soil fertility, carbon sequestration, and biodiversity. But the research also found some synergies. When farmers focus on improving crop quality rather than just yield, they can actually enhance ecosystem services. The other example is from a paper published on Scientific Data in 2025, also this year. The goal of this paper is to identify the areas or sites where conservation can be achieved at a minimum cost in Europe. For that, the authors calculate the opportunity costs or the foregone economic benefits from using land for other activities like agriculture, forestry, and urban use instead of conservation. In other words, the opportunity cost is calculated as a resource rent in the case of agriculture and forestry, and as a residential rent in the case of urban areas. The final map of opportunity cost, which is the one you see here in the screen, can be used as a decision support tool in conservation planning and land use policy. Essentially, it shows where it is more or less costly to conserve land, allowing decision makers to design more efficient strategies. In this specific case, darker areas are areas where it is more expensive to conserve lands, because those lands are very productive or valuable for other uses, and lighter areas are cheaper to conserve, meaning that those lands generate lower returns from alternative uses. Now attention, ideally we don't just want to conserve the cheapest land. We want to conserve the land that is most valuable in terms of ecosystem services and biodiversity. And that is why the opportunity cost map becomes even more powerful when we combine it with other spatial layers. For example, maps showing biodiversity hotspots, carbon storage, or watershed protection. By overlaying these maps, we can identify areas that offer high ecological benefits at relatively low economic costs. In other words, we can find, or at least try to find, the win-win zones or areas where conservation gives us the biggest environmental return for each dollar, or in this case euro, invested. So to conclude today's lecture, I would like to emphasize that in a world of limited resources, every choice comes with a cost. Understanding scarcity, trade-offs, and opportunity costs allows us to see what we gain and what we give up when making decisions, hopefully smarter and more sustainable decisions. As always, I hope this lecture has been helpful to you. See you in the next video where we will talk about when market fails. See you then. Bye.